Solve the initial value problem. That's the next question. Uh, if you look at this question, let's look at it. You can see the x here, you can see the y here. Okay, let's try to rearrange that to bring them together. Let's see. This will be equal to the solution. That will be equal to 3y x squared dx. Move this one to the other side, and that will be equal to minus into brackets x cubed plus 2y to the power 4 the y. So, but if you look at this, the standard form is of this form. The standard form um, is this way, the standard form plus n the y equal to 0. Okay, this is also equal to 0 because when you move this one to the other side, this will become equal to 0. So that's equal to 0, equal to 0. Okay, so what we can do now, we can force this to be plus by allowing this negative to come inside. So we now have 3y x squared dx plus, allow the negative to come inside that bracket. That will be minus x3 minus 2y4 the y. Just want to avoid mistakes and want it to look exactly like the standard form. Actually, we are not sure whether this is whether it's exact, whether it's something like that. But once we follow the standard form, then we know that the step to take will be exactness of the equation. We have to check the exactness of the equation. Is the equation exact? Since it follows this format. Once you follow this format, then you can test for the exactness of the equation. Okay, that's the exact differential. Okay, so it's conformed to the standard form. So let's go straight to the work. The attachment to the x is called m. M as a function of two variables here is equal to 3 dex. Dex. Can we get the partial differential of that respect to y? Okay, and that will be equal to respect to y. Once you have the partial differential, just do for that function, which is what y here. So that's one. This is what we are differentiating. Others are constant. That 3x squared. Then the other one, n, the attachment to the y is called n. N is what? Minus what? Minus x cubed minus 2y4. Then the partial differential of that respect to other function, respect to x, that's equal to minus x3. So this is what we have for, this is what we have for. So we can get the partial differential of n respect to x. This will equal to minus 3x squared. Here it doesn't have x, so it's the constant is 0. Okay, so does it exact? Does the two equation exact? No, so it's not equal. Dex and dex are not equal to each other. But that's not the end of the road. Let's still wait for we can make it to the exact. Okay, let's check. Let's check this equation. Y dx all over n is a function of two variables. Let's see if we are going to have one function. Okay, my partial differential of m respect to y is 3x squared minus partial differential of n respect to x is minus, so that becomes plus 3 what? 3x squared over my n is what? My n is minus x cubed minus 2x4. So I don't have to continue. This one contains it's a function of what? It's a function of x and y. I just need something that will give me a function of two variables. Okay. So this is the equation we use to convert unexact to exact. Let's check the other one by reversing the process. This one to come forward. This one, this minus delta m over delta y all over m. Let's see that. So that was minus 3x squared. Okay, minus that's also that function all over, which is equal to minus 6x squared all over m. My m is what? My m is 3 at y x squared, which is over 3y x squared. X squared will cancel. Then I have I have what now? I have 6 over, that's minus 2 over y. So this is a function of, this is what? This is a function of one variable. This is a function. This is a function of one variable y. So then we can get the integral factor. So integral factor will now be equal to what? E to power what you have here. And we have the answer as what? Minus 2 over y dy. That will be equal to, you can take the 2 out. That will be equal to e to ln y minus 2, which is equal to y minus 2. We don't have to waste our time there. So that's our integral factor as a function of what? As a function of y. So since you've gotten your integral factor, once your equation is not exact, the next thing is to get your integral factor. Okay, and what are you going to use that for? Very simple questions. The answer is just to use the integral factor to multiply the given problem. Use to multiply the given problem. Okay, and automatically with that, your equation will become exact. Let's just do that. So we now have now y minus 2 times 3y s squared dx plus y minus 2 times minus x3 minus 2y power 4 dy equal to 0. Okay, so this will be equal to that is equal to 3y minus 1 s squared dx, then plus minus x3 y minus 2 minus 2y 2 dy equal to 0. So automatically it will be exact, but let's show it. So your partial differential, your m respect to y, this is your m respect to y will be equal to, if we differentiate this, that will be equal to 3 minus 3, the minus will come from front, okay, y minus 2 s squared. I told you, you only differentiate the y when you are doing partial, then you keep other variable constants. Let's also check this one. The n respect to x, and that will be equal to, you're only keeping this one constant, and that will be what? Minus 3 x3 minus 1, that's 2. This is constant, y minus 2. So here, there is no x here, so it's constant. So I don't even need to show this, because once you have your integral factor, automatically you multiply the given problem by the integral factor, automatically to be exact. So this is now what? This is now dex is exact. Okay, it's exact now. So in that case now, since it's exact now, then there is your new function now is now this. You have no issue. You have nothing to do with this one again. This is your standard. This is your standard equation now. This one is your standard equation after multiplying with the integral factor. So there is now a function such that partial differential of x, okay, is equal to what? Is equal to partial differential of f respect to x is equal to m. Okay, and that will give us f equal to integral of our m function as a function of two variables is what? We have the m here, which is the 3y minus 1 times the x squared, then delta x. Then put the constant of integration there, which will be g of y, because you are integrating with respect to x. Okay, let's get the integral of this respect to x. So that will be, you are integrating partially. You have to know that partially respect to x. Okay, so that means you just look for the variable x and integrate that, and that will be f will be equal to 3 minus 1, 3 times y to power minus 1. Then this will be what? X 3 over 3. Then plus what? G of what? G of y. So 3 we cancel here, and I have f equal to what? F equal to y minus 1. 3, that will be x to power 3, y minus 1. Okay, plus g of what? G of y. Then we want to get, this is our solution, that's our solution, but we need to get the g of y. So how do we do that? Differentiate with respect to y. So we have this respect to y, which is equal to n, and we have the value. N is equal to what? N is equal to minus x3 y minus 2 minus 2y squared equal to, differentiate this, that will be 3 respect to y. If it's respect to y, I'm only after the y variable. So I'm only after the y variable, which is equal to x3. Differentiate this, that will be minus x3, okay, y minus 2 plus what? Plus g of what? G of y. Okay? So with that now, you can see that if this one move to the other side, become plus. So this one and this one will cancel, and I have my g of differentiate. When you differentiate this one, it will be g prime. So g prime equal to what? Equal to minus 2y squared. Okay? So then integrate both sides with respect to y. Integrate with respect to y, both sides. So g of y equals to what? Integral of what? Minus 2y squared dy. And that will give me minus 2y3 over 3 plus c1. So that's my g of y. So finally, I'll just have to go back to where we have the f, which is this equation, where we have the f. Where's my f? Yeah, here. Just come back here. So, and don't forget that your f is c. Okay, let's write it. That will be f equal to x power 3 y minus 1 plus minus 2 over 3 y cubed plus c1. So the solution is this is c. F is c. F is capital C. So minus c1. So that will be x3 y minus 1 minus 2 over 3 y cubed equal to c. So that's the solution. But I think we are giving some conditions here. Condition, we have this 3, and that's just for to get the c. This is x value and this is y value. So let's do that. Now x is 0. This is everything becomes 0 here. Here we have minus 2 over 3. Y is what? Y is 3 cube. That's 27. Okay, equal to c. So 3 here 1, 3 here 9. That's c is minus 18. C is minus 18. So that's the value for c. So we just go back to the final answer. The solution is now what? The solution is this one over y minus 2 over 3 y3 equal to minus 18. So that's the solution. So you can leave it this way, or you can remove that minus 1. So that's the solution to that question.